we're talking about RAG, retrieval-augmented generation today. That's one of the aspects how LLMs, large language models, are used. So we'll be talking about this specific framework or specific idea of using LLMs for own data. That's the main theme of talk today. Why do we need RAG? I've listed a couple of points here, but I'll elaborate them one by one in the later slides. As you know, LLMs like GPT-3, 3.5, Palm, Gemini, and then front ends, ChatGPT, Bard. Those are heavily used and they've been very popular. But these are very popular, in my opinion, in such a playful kind of manner. But if you at all you start using them for enterprise applications, industrial applications, then some other aspects come into picture. And those aspects are, you have to be cost conscious. You cannot like fire millions of requests, which enterprise software may fire. So there we have to consider cost. Of course, another aspect is privacy, because GPT or whatever, whichever publicly available, closed or open source language models are available. They are based on, say, internet public data. They are not built on your data, right? So we have to have something that uses our data and very reliable solutions. You might have heard the term, which is the hallucination. These language models, most of them, give very blatantly wrong answers very confidently, like many humans. So these things, hallucinations, factual errors, these are not allowed in enterprise software. Right? More serious mission critical softwares, if you are using it for medical applications, say legal applications, this is not allowed. If you're writing a story fiction, probably it is okay. But for serious applications, that's not okay. So we need something for own data, the third point, private data. Streaming data, the data that is coming, it is not batch, it is not there somewhere, it is streaming, and latest data. As you know, ChatGPT is built on data which has been till some time. It used to be September 2021, now it has been shifted a bit. But many LLMs are built on some past cutoffs, right? It does not have today's data. Of course, there are some solutions which say Microsoft Copilot and Google also. They bring search-related latest data also, but more or less, the LLMs do not have latest data. So these are some of the issues for which RAG has been sort of devised or invented. So we'll see these points again one by one. Another point that I'll cover is RAG versus fine-tuning. Meaning, if you want to build something custom based on your data, there are primarily these approaches, RAG and fine-tuning also. We'll see basic comparison between them. So that's the idea of this talk. By the way, at some logical end, I'll stop so that you can ask me questions. Okay, that's the modality. So, of course, the ready elements like GPT or Llama 2 or Gemini or Palm, these are based on internet scale data. But they don't have access to our data. Our data may be in our file folders, our databases, our own private repositories. So how RAG enables accessing that data, which is not available in the standard LLMs, right? So that's one aspect. Another aspect is my data may be updating all the time. New records are fed into my database. Now, how can we incorporate that updated knowledge for building chat-like application, still leveraging LLM? So that's another point. My data knowledge, updating, maintaining the latestness, being updated all the time with the knowledge base, so that LLMs can use this updated knowledge knowledge base to answer questions. That's the basic idea, right? You want to build a conversational AI chatbot-like application using LLMs, but on my data. If I don't have requirement for my data, the standard chat GPT or Gemini or Bard is good enough. So that's not the case. But you want to answer, you want answers based on your own data. That's the basic theme of doing RAG. Another thing, as we said, LLMs may hallucinate, give factual errors. We want some confidence in the response, meaning we want to ground the responses. Grounding, they have to have factually correct answers from my database. So this is one of the requirements, as we see, very crucial in enterprise applications. You cannot go wrong, as I said, in financial reporting. If you ask what was my sales in last quarter, you cannot just give some figure, right? It has to be very correct. It's almost like an SQL query that should be fired, and you should get the correct answer. Being context aware. That's another point. So you're talking something, but if you're talking something about set, SET set. So this set word can come in multiple scenarios, right? Set is there is a mathematical set, a programming set, set is setting of cement, whatever. So one has to know my context, right? Context aware is another requirement. And one more requirement which is very crucial, and it is still not there in ChatGPT, but it is there in Copilot now or in Perplexity, is source citation. Whenever you are getting a response, where is it coming from? The source. How does it help? It brings transparency. It also brings, I can cite it. I have not cooked it up. That's the confidence one gets. So these are a couple of aspects for which RAG is helpful there. And of course, reduced hallucinations, meaning the answers, responses have to be factually correct. They have to be correct and not blatant lies. And last thing is, we have actually this is practical empowerment, meaning they have to be practical. This solution, RAG or whatever solution, has to be practical, implementable, building confidence, those aspects. So these are aspects with which, for which RAG has been devised. This is basically the architecture. We'll have a look at it in more details. Okay, so this is just a summary. I will wait here for a second. You can read through. I'll also go one by one. These are the questions we are trying to answer using RAG. While building a LLM application, GPT application, or large language model, or chatbot-like application, do you need external data access, meaning the data that is not there in LLM, well, your own data? Do you want to modify the way foundation model, meaning the standard LLM is answering? Do you want to address factual errors, hallucinations? Do you have label data? Meaning you want something on your domain, but do you have data, label data about that domain? Do you want citations, meaning source of the information? How critical is fastness, latency, speed, performance? Are you concerned about cost, scalability? And then do you have expertise to implement RAG or fine tuning or any other thing? These are very important questions business-wise. They are sort of technical also, which needs to be answered before moving forward. If there is no almost to everything, then standard LLMs are good enough. Why go for something else, right? But if some of the questions are positive, then of course you can think of RAG and in some cases fine tuning. We'll discuss that. I'll stop here if there are any questions at this moment. Maybe just one or two questions.
Yeah. So one question is how, like, does RAG Or can RAG actually detect if the answer is a part of an hallucination? Like, is there a way to
Yes.
like find out if this is a hallucinated answer?
Correct. I'll explain that. So we can definitely check, in some, of course, in some cases where the answer is coming from say my database, basically. Right? If you have asked for the last quarter sales, and if some response comes, then at least in say manual mode and in some semi-automatic mode, you can cross-check, right? If it is really happening. If it has
Correct.
got
Yeah.
quarterly sales and then total sales also, you can just sum it up and see if the total is matching up, if it is adding up,
Correct.
basically.
Yeah.
So, as the answers, I'll explain the architecture, then I think it will be more clearer. If the answers are making sense from my data source, then of course you have reduced hallucination, right?
Okay. But like in case of like textual data or maybe code generation, like we have GitHub Copilot, right? For example, I'm asking GitHub Copilot to give me a code to do, let's say, task X, but it gives us that
Correct.
particular code. So sometimes it has happened that it has given, let's say, a Java code, but that Java
Correct.
code, when we run, it seems that this particular module actually does not exist. So it's like hallucinating.
No, that's the problem. Even RAG may have, right? Since it is not 100% correct solution, because there is a LLM component also in it. So we still have to have all the accuracy checks, post-response checks in place. Even if RAG just reduces hallucination, not eliminates hallucinations.
Okay. Right.
All right.
Thanks.
Uh, I think I'll move ahead. So we'll see. This is the diagram. If you don't take anything from this session today, this is the diagram you should take, and that's about it. Further talk is just developing on this diagram. So how does it work? Okay, I've got it from this wonderful person. You should. I suggest you follow him on LinkedIn. Wonderful post that he does on RAG specifically. So what happens? You are using ChatGPT or Bard or whatever, but of course, Bard-like application, I would say, because we have implemented RAG now, is our application. So we have put prompt. The prompt goes, so prompt is put one. It goes to search relevant information. Say you have asked for the sales of the last quarter. Uh, GPT 3.5, Chat GPT or Bard does not have that answer. It is private data. So it somehow, we'll see how, somehow converts this prompt, this query, into say SQL. Just assume. Or it searches for this information in the knowledge sources. Let's do that. And it brings relevant information or relevant text or relevant paragraph having this information. Right? Number three, a relevant context is brought based on the query. Okay, maybe a couple of rows in the table or whatever. Right? Those things are brought. Now, the original prompt, along with the context, they go to the LLM, meaning GPT. Right? So prompt was giving last quarter sales, and now we have brought externally 3-4 rows relevant to last quarter. Now we are asking answer the prompt, meaning original question from the given context only. That's the idea. That's the core idea. We have brought ready context to LLM and that goes to it, and then LLM replies back given the context, in the given context. Of course, the context is little odd than the original question, then it may have his LLM's own hallucination or whatever creativity kicked in, right? But if the answer is there, generally it is supposed to answer correctly or better, answer better, isn't it? Now we are not asking this prompt to a raw LLM. We are giving it a context. It's almost like few shots, if you are aware of it. Some examples have been given in the prompt itself. So that's the idea. And response is given, say 5. That's the core idea and that's about it. Further things are just refinement of these individual components. Uh, any questions here? This is the core slide and everything else is just details. All right, wonderful. We'll move ahead. Same thing. These are the steps 1, 2, 3, 4, 5. So there are two main components, if you can imagine. Indexing, meaning how do you create this knowledge base itself? So if you have say 1,000 HR documents or my books in PDF format, so you have to keep the knowledge source ready to be searchable, right? In some sense. So typically, what we do, we keep our knowledge in index format. If you have heard of Elasticsearch or whatever, these are indices, index. So you take your knowledge, all documents, chunk them, meaning separate them, so that you cannot build a complete vector or other numerical representation of whole books, right? So you chunk them, vectorize them. If at all people are not aware of vectorization, I'll explain that. But this word embedding like vectorization, keep all these vectors in a database. And this being a vector databases, they are called as vector databases, vector DBs. So you index all those vectors and keep it ready. Then when a new prompt comes, the prompt is also vectorized similarly. And then matching happens for my vector, which vectors are closest, top 3, top 5, right? These vectors and their corresponding text is brought into the prompt. Getting what I'm saying? So there is an indexing pipeline which creates knowledge source, vector database basically, and then there's a retriever. Retriever does similarity search based on my prompt, which are the most similar 3, 4 textual portions which I should bring it to the prompt. That's the indexing pipeline and generation, retrieval generation pipeline. So these are the two main components of RAG. All right. So now things are, I'm explaining it in quite a few details. Um, Maybe I won't read through, that will be a little tedious, but I'll explain the indexing pipeline in a little more detail. Assume that we have 1,000 books, 1,000 pages. Each has 10 pages or 100 pages. All these pages are read, all the paragraphs, by some chunking mechanism. Chunking means separation, segmentation. I segment all the text, all the pieces are converted to vectors and they're indexed. So that's what is explained, vector database generation. And then while retrieving, as I mentioned, you can vectorize the query also, search through all those databases, and you can have efficient algorithms for searching, not go on all other searching everything, but we can do clustering and other things. Some efficient mechanism of searching can be employed, and then you bring in the context. So this is what has been done. So RAG step by step, chunk, embed, index. First step. Utilize nearest neighbor. Maybe 3, 4 contexts are needed to match the query. Retrieve the retrieval context from vector database. Augment the LLM prompt in the retrieval. That's it. These are the 4 steps. If you understand, good enough. And there are, of course, various frameworks. So there are many vector databases, Pinecone, Grova, Vivian, whatever. N number of databases are available. There are frameworks that orchestrate all these things, and one of the famous one is LangChain. And of course, all these cloud platforms, Microsoft Azure or AWS or GCP, they'll have their own ways of doing this pipelining, RAG-led. So that's the idea. Of course, LLM, like standard LLM, we can have, because LLM, as you can see, is used in the embedding mode while indexing and while generating the output, right? Because finally it is prompt and context. So the LLM plays picture. Then you can, of course, have your standard parameters like temperature, top K, top P, and many other things, those things. So as I was answering, the hallucination part, it is not fully eliminated, but it is reduced because we are giving a context, but not fully eliminated because LLM is still in the part. And things can go wrong while embedding, while matching, while generating. All all three places there could be errors or non-semanticness, non-meaningness. All right. How do you evaluate? Similar to any NLP-like application, NLP is natural language processing, rules, view, and many other evaluation criteria. This is really tricky in LLM sense. Let's take one example. You are doing summarization application. You have a paragraph. You want to reduce it to three lines, and you have a golden answer also, golden summary. Now, this paragraph has been reduced to predicted summary, 3 lines or 4 lines, and there's a golden 3 or 4 lines. How do you match whether the summary is correct or not? Meaning wise, word wise, it may be different, isn't it? So it's not word to word comparison. So evaluation itself is tricky business. You can use LLM there also, whether these three or two things are similar or not. But that again is a little shaky, right? It's not deterministic. So evaluation is also challenging in case of LLMs. If it is normal classification, whether the sentiment is positive, negative, straight away, right? 0, 1, 0, 1, that comparison, you can have deterministic accuracy. Not the case with uh, text output, right? You have to be semantically evaluating things. Uh, Pros, of course, more factually correct and diversity, you can have your own data. Cons, of course, you have to have another network now, another orchestrated system to do this. Your data may have bias, who knows, right? And then, of course, all this compute, um, vector database, their money, LLM money, everything is there, right? So, pros and cons. I can go in details now, but any questions so far?
Yogesh, how does like you mentioned about vectorization and like embedding all what we have, right? So it can be a
Yeah,
multimodal format, right? It can be PDFs, it
yes,
can be code. So for example, like
yes,
GitHub Copilot, it can be code as well. So
yeah,
eventually, how does like it knows
correct.
that this is code and this is not an image of a code, and like exactly differentiating different models. So
That's a
can
very
you spread
tricky
some light?
question. No, this tricky question, but I'll just give you a very vague and superficial answer. By the way, text and code all would be text in some sense as far as modality goes. Mode is text.
Correct.
But as you're talking about image plus text, when you have written a prompt,
Mm-hmm.
give an image. How does it search image?
Correct.
Eventually, in the vector space, both are vectors. But of course, there has
Uh-huh.
to be some mechanism that it brings image vectors only, right? And not because the prompt has asked for it. So that's a little tricky, but I'm sure while doing similarity, you may have
Mm-hmm.
subspace in the index database that these are the images, but still match with this vector. So vector to vector matching is same, irrespective of whether it is a text or
Same.
an
Yeah.
image, because they've been trained.
Mm-hmm.
There used to be networks like Siamese network. They'll do different kind of modalities, two tower models and others.
Uh-huh.
But essentially they are vectors. But now that prompt has asked for vectors, you cannot bring in like code vector. Right? You have asked for the capital of India. You cannot bring code. So that
Correct.
separation,
Correct.
that segmentation has to be there. Some mechanism. I have not, of course, dealt with that yet. I'm still in text. Yeah.
Uh, and on the evaluation you mentioned for like summarization, it's still tough, right? So are there any
Yes.
tools like you mentioned one of them for summarization which can summarize in 3 lines and still check if the meaning is correct?
Yes. There are multiple approaches. This is a classical text similarity problem, isn't it? You can do word by
Mm-hmm.
word, you can do rule based, you can do LLM way. There are N ways of doing it, and you can apply anything that works for you basically. And the standard tools are standard tools, meaning embedding based search or keyword based search, topic modeling based search. You can. This is
Can
a
we like,
standard.
is there a, yeah, is that a good way to have like lemmatize it and then create like small lemmas and then see, vectorize that
Absolutely.
and see if they
Absolutely, even topic modeling works.
properly.
But if you're not a deep enough standard LLM call, give these two texts and ask whether they are similar.
Yeah, this is it. Okay.
Yeah. All right. We'll move ahead. Uh, I will go a little fast now that we have understood what the RAG or this is actually a naive RAG, right? Whatever we have seen so far. These are the steps. You query, retrieve document, generate summary, and that's about it. So this is how it works. Documents are indexed in some database. User query comes, some retrieval happens. Prompt plus context goes to LLM, and that's the response. Standard. Now, at all these stages, we can bring some advancement, and we'll see how advanced RAG works. I'll not go into too many details, but I'll just mention where the advancement is possible. What's the problem with live RAG? Quality, of course, you may still have hallucinations. Quality, many standard problems that you may have. So there are three pre-retrieval, retrieval, and post-retrieval. At all three stages, we can do some enhancements, and there are many enhancements still coming because this RAG itself, as we can imagine, is a very naive field as of now. So more and more advancements are coming. I'll show you one picture which will make things clear. So this orange thing was our standard live RAG, right? Documents getting indexed. Now, by indexing, you can have many advancements. Chunk optimization. Given a text, do you do sentence tokenization, that is sentence-wise cutting, white space cutting, theme-wise cutting, or what? If you have table, what do you do? If you have diagram, what do you do? So, chunk optimization, in my opinion, is the most critical part of RAG. You integrate metadata also. Where this paragraph came from. Metadata, data about data about the data. Isn't it? That's the thing. For source citation. Indexing structure. Do you store linearly? Do you store in tree format so that the search becomes fast? Or is it inherently graph indexing structure? Llama index, which I've heard, they have got quite a few indexing structures, right? And they leverage it very well. Alignment. Do you do medical related, image related things separately or something? Alignment has a different meaning also. Let's relate to elements. Human alignment, human values alignment. But for now, we'll say alignment in terms of say modality is one way of doing it. So pre-retrieval, you can have many enhancements. While retrieval, basically that is search, embedding, making close enough semantic embeddings and searching them very correctly. That's the part. Post-retrieval. Post-retrieval could be simplistically, you have got responses, 6-7 responses are eligible based on cutoff, 80% similarity. Can you rank them? Re-rank them. Even though it says 95%, 90%, 85%, 80%, and 70%. Is it really that order, or should I change it based on my external another set of knowledge or rules? Re-ranking. Even another thing is compression. You want to do summary of 100 books. Now each book has brought you some summary. That summary is also long enough. Do we compress it again by summarization, re-summarization, and then put it in prompt? Why we have to compress it? Because as we know, the inherent limitation of prompts is token limit. So say GPT 3.5 has 2000 tokens allowed. Tokens, if you don't know, it is word or subword thing. For 2000, there could be 1500 words roughly. But assume for this session, at least the number of words. They are not actual number of words, they are some words. But you have a limit. So input as well as output has to fit in 2000 words or 4000 words. So compression has to be done. So this is another slide you can take home. First is the live RAG, this is advanced RAG, and advancement is done this way, or this way. Further slides are based on these advancements. I'll quickly go further and talk about another prominent topic, which is RAG versus SFT. I'll explain that. and then I'll close. Any questions here? All right, no problem. So further slides explain the same thing, chunk optimization, meta-data integration, which I've explained. By the way, this presentation I'll hand it over to Kasam, or it's available. At least the source code of it in native format is available on the GitHub for everybody to use it also. You can copy and use. It's kept open. Okay, these are some of the things. Same thing, post-retrieval anything as we just discussed. Now, another important topic that I wish to discuss is you want to build something on your own data, right? And we saw one mechanism called RAG. You index it and then use it while training. Another thing is you can fine tune the base model. Base model meaning foundation model, GPT 3.5. By the way, ChatGPT is actually fine-tuned version of GPT 3.5. It has been trained on the conversational data, labeled data. So that decision is again very crucial. And we will see some of the points related to RAG versus SFT. By the way, fine-tuning, if you are from deep learning background or machine learning background, you would understand. You have some model, neural network, but it is built on some, say, ready data, like LLMs. But you have your own domain data. What do? We keep weights in the earlier, or almost all the layers, but change the final layer to do our kind of output. And supply our data, and then just retrain it, you can say, or have auxiliary data. I'm just giving you a very superficial idea. But if at all you're interested, you can discuss this further. So there, the neural network weights change in one case. In another case, we can have auxiliary network on top of foundational model network, which is specific to our domain. So these are two ways which pamper the neural network. RAG does not pamper the neural network. Okay? So these are two ways, and we'll see where to apply, which to apply where. Okay, that's right. So RAG is just external fetching. If you can remember, you fetch the index data. That's about it, and you get that context and answer based on. SFT is different. SFT is actually the model changes, or we have additional adapter model on top of it. So at least the set is different than the original model, isn't it? So these are two different ways of using your own data along with the standard LLM, foundation LLM. All right. This is another important diagram. How do we choose? RAG or SFT? Now, it's very simplistic. If you don't have label data, by the way, as we can say, good enough label data, I would say, right? On the right hand side. Then, if you don't have that, even if you have 10 records, 5 records, put them in index and start using it. RAG is preferred, isn't it? But if you have a lot of data, like as if, say you are in the finance domain, you have 10 years of data, and that is available. Why not fine tune? Because it then becomes your verticalized model, isn't it? So SFT is preferred if you have good enough, nice data, curated data. Not, of course, like whole internet data, but good enough, right? So there SFT is preferred. If you don't have that kind of data, then RAG is preferred. That's the bottom line. That's the intuition. Yeah. Probably that's about it. Further slides I'll quickly cover, and then I can take questions. Applications are generally known. Yeah, these are the tools. If you have not heard, you should. So many of these libraries are helping building RAG. LangChain is very famous, Llama Index. Of course, these models come from Hugging Face, you've heard. There is a Transformers library. And many such models are there. All these big cloud guys, Azure or GCP, they'll have their own system doing RAG. Of course, some of them may not be open source, or many of them are not open source, it's closed source. And data sets and evaluation network. These are the things that we typically need for doing RNG. Then, of course, a few slides on LangChain. LangChain is actually a wonderful, simple system. It's orchestration. Orchestration in the sense you can call any model which is available on Hugging Face. You can also call GPT models. They have got their own APIs available in LangChain. You can call Gemini model, Google's models. Just by changing the word model name and then giving some access related tokens and API tokens, you can invoke, you can call these models. The rest of the things change. So if you're working on say GPT 3.5 and tomorrow you have been asked to do some GPT 4, just change the model name, have enough access to those models, and the rest of the code remains same. So a nice abstraction. So LLM abstraction is there, prompt abstraction is there. You can call vector databases, different vector databases. You can have agents. Agents which have learned, these are the guys who can do some specific work based on prompt. You can have tools, search tools, calculation tools, and all. So there's a wonderful framework that has come up, open source, free to use, and then you can build RAG systems very well. I have a couple of articles on Medium. If you search my name, Yogesh Kulkarni, you get a couple of examples of using LangChain. And there are different models, open source models also, some closed source models also. Yeah, you can do almost everything that LLM does via LangChain. Yeah, that's about it probably. What is RAG? Uh, that's the framework to build something on your own data, external data. This is a very comprehensive figure. I'll wait here for a second. I've gone a little fast, but still, I'll wait here for a second so that we can assemble it. And you can now correlate. You should be able to correlate whatever we have spoken for half an hour, 40 minutes. I'll stop here for questions. Rest of the there are just one or two slides. Any questions here? All right, wonderful. I'm assuming. Yeah. So, some summary, some conclusions. I won't read through one by one, but these are the things that we discussed. Why we need RAG, two pipelines, indexing and generation, and retrieval evaluation, some sense of evaluation. Challenges, of course, all the advancements that we have seen, three portions, they are still not like 100% correct. Advancements will go on in this structure. If you can imagine, if you want to bring tabular data into prompt, how do you bring? Right? If you have finance application, and then multimodality, another thing, if you have data in images, still RAG should bring in some sense. And those challenges are still there. Another important domain is if you have data in graphs, knowledge graphs, how do you fetch it? There's some work going on there as well. So these are some of the future directions. If at all you're interested in connecting with me, that's my I think LinkedIn profile thing. You can follow me. My connections are full. Any questions? I can take up now.